Okay, alright, so yesterday we talked about determining if something was a function or not. And on the vertical line test, if it only touched the graph in one spot for each vertical line, then it was a function. And what was the biggest deal? That it could have no y squared in order to be a function, and also if they gave you ordered pairs, how could you determine? What can't be repeated? The x value. The y values can repeat all they want, but it's the x value that can't repeat. And the reason that the x value can't repeat is because that makes a vertical line, which makes an undefined slope, which makes not a function. Okay? Today we're going to compare functions based upon their slopes. All right, so it's going to be skills that we've already done before, except for one. All right, so we can compare functions by looking at their properties, such as their slope or rate of change. Okay, how do you find slope from a graph? Karen? Rise over run. How do you find slope from 2 points? How do you find slope from a table? There's 2 options. Changing the y over the change in the x, or like Kate was saying, you can circle 2 points and use the slope formula. Either one is fine. So to find rate of change, you can use slope formula, which is y2 minus y1 over x2 minus x1, or you can compare the rise over the run. You hear that music over there?
Kate's the one more music.
And Kate's on
It's hot, look.
Okay. Alright, so, guys, let's read the directions. It says practice finding rate of change in the following example. So it says rate of change, and you all have to know that rate of change is also talking about the slope. Slope and rate of change are interchangeable words. So when I'm looking at number 1 here, somebody raise their hand and tell me what the slope of that one is, Audrey. 2/5. Because if we are looking at an equation, it's y equals mx plus b, m is the slope, and b is the y-intercept. So if you forgot that, you may want to jot that down again. So the slope is the number that's in front of the x. All right, number 2. How would I have to find my slope on number 2? Trevor? Slope formula. Because this is the first point, so I'm going to label it x1, y1. This is the second point, so x2, y2. So 9 minus 7.5 over 6 minus 5. So y2 minus y1 over x2 minus x1. So that's 1.5 over 1, which is 1.5. What fraction is 1.5? Which is what improper fraction? 3 over 2. All right, number 3. It's a table. So 2 options. You can choose 2 of the points and do just like we did on number 2, or you can find the change in the y and put it over the change in the x. I personally would just find the change in the x over the change in the y. So -5 to -11. How do they get from -5 to -11? -6. How do they get from -11 to -17? So the change in the y is -6. And then look at the x. 5 to 7 is up 2. 7 to 9 is up 2. So that's -6 over 2, which is -3. Or you can circle 2 points, label x1, y1, x2, y2, and do slope formula the same. All right, number 4. How do you find slope from a graph? Rise over run, but you have to look for 2 points that go perfectly through the corner of a box. So it's typically pretty safe to choose the y-intercept, and then I can probably choose like that one, okay? All right, so rise over run. So I rise 1, and I'm making sure that I'm looking at what it's counting by, and I run 1, 2, 3, 4. So that rate of change is 1, 4. All right, so that was just our little refresh for what we're going to apply today. Are there any questions about how I got those? Okay. All right, so number 5, it says use your knowledge of rate of change to help you compare the following functions. So it says Ty sells signs in a monthly craft fair, and he can make 7 signs every 2 hours. His friend Harrison helps him make signs, and the rate at which Harrison makes signs is in the table below. So part A says, who is making signs at a greater rate, and how do you know? So what is Ty's rate? What's it say about Ty?
3 hours.
So 7 signs for every 2 hours? Right? I always just think of it proper. You can think of it as 3.5 if you want, or 3.5, but I always leave mine like that because I can tell some fractions too. All right, and then I'm gonna have to look at Harrison's. So it's a table. How can we find rate of change from a table? Either by choosing 2 points and doing slope formula, or just by finding the change in the y over the change in the x. So on a table, the x is on top, y is on the bottom. All right, so how do they get from 0 to 15? 15. What about from 15 to 30? 15, and 30 to 45 is also 15. So it looks like Harrison's change in the y is 15, and let's look at the hours. 0 to 4 is 4, 4 to 8 is 4, 8 to 12 is 4. So he's 15 fourths. Okay? So we said this is like 3 1/2 or 3.5, and 15 fourths is 3 3/4. Right? So who's making the signs at a faster, at a greater rate? Harrison. And so we're going to say Harrison. And it says, how do you know? And we're going to say because Harrison's rate of 15 fourths is greater than Ty's. When you all take iLearn, they aren't going to want you to say Harrison because it's bigger, because it's greater. Like, they're not going to want something short and simple. They're going to want an explanation where you really say, okay, because Harrison's is this and Ty's was this and Harrison's is greater than Ty's. And they want something more elaborate. All right? All right, and then part B, it says after 12 hours, what would be the difference in the number of signs that each friend has made? Right, you already know.
Hold on. I was just gonna say underlying difference.
Yes, yes, and difference is what operation I'm at. Subtraction. So I'm gonna have to find how many signs Harrison made at 12 hours, how many signs Ty made at 12 hours, and then subtract them. All right, so this 2 is the amount of signs, this 4 is the amount of signs. Oh wait, no, that's the amount of hours, sorry, amount of hours. So I'm gonna have to count until these are at 12, and then this top number will tell me my amount of signs. Okay, so I'll start with Ty. So he's at 7 halves, so then it would be 14 fourths, and then what?
21 6.
21 6, 28 8, 10, 42, 12. So we made 42 signs. Is there another way that I could have figured that out other than counting? Brooklyn? Okay, well, not exactly, because we don't know. Well, I guess you could have done that because 2 times 6 is 12 hours. Yeah, I guess you could have done that. Preston? Yes. And that was the other way. You could have changed that into a function, like y equals 7 halves x. Like y equals 7 halves x, and then you could have done 7 halves times 12, and that would have been 42. You could have done it that way. All right, let's find Harrison's. So you can find it either way that you want. Put hair there. So why don't you either count?
It's already very simple.
Oh, it is. Oh, look at me not being observant. Right there. So 12 hours, he had 45. So 45 minus 42 is 3 signs. Good job being observant. All right, I want you all to flip it over, and I want you all to do number 6 by yourself. Give you a minute to do that one. Of course. Yeah. You can always use one unless I specifically tell you no. On iLearn, it will be like calculator and no calculator sessions. Yeah, so if the calculator button pops up, then you can use it.
You're not allowed to use your own.
Yeah, yeah, like his wouldn't be accepted. Unless like when I had to take like a state test, like for my license to be a teacher, I used one of those, but when you went into the room, they completely wiped your memory. Like you came to the room, you sat down in your seat, you put your calculator on, and they came by and reset them all. Yes, sir. Yeah, there's plenty over there. In that blue box. I put them in a box because they kept falling off into the trash can. Hey, you're back. We're on number 6. Okay, so Julie's family is filling up a pool in her backyard. The equation y equals 5.2x plus 8,400 can be used to show the rate at which the pool is filling up with water, where y is the total number of water gallons and x is the amount of time minutes. Her neighbor Elena is also filling up their pool as shown in the table below. Whose pool is filling up at a faster rate and how do you know? So we first have to find Julie's rate. What is Julie's rate? 5.2, and we know that because when we talk about rate is talking about the slope, and we know that the slope is the number in front of the x, so 5.2. Okay, so Julie is filling up at a rate of 5.2. What would the label on that 5.2 be? Gallons, what? Per minute, okay? All right, and now I'm gonna find Elena's rate from that table. So once again, you can either choose 2 points, do slope formula, or you can count. What did you all do? Count it?
I use slope.
Okay, I don't care. All right, I'm gonna use these two just because it's not a decimal. So x1, y1, x2, y2. So 7874 minus 7850 over 5 minus 0. That's 5 on the bottom, 24 on top, and what's 24 divided by 5? 4.8. So Elena's at 4.8 gallons per minute. So whose pool is filling up quicker, Taryn? Julie's pool. And it says, how do you know?
I also want to say,
Yeah.
I changed 5.2.
That's okay.
What?
So what is that? It's 5 and 1/5, so that is 26 fifths. So that's what.
And it's filling up, Floyd's filling up faster because she has 26 fifths and Elena only has 20.
Right. So in your explanation, I'm not gonna write it all out, but you should say something like Karen said, you could say Julie's is filling up faster at a rate of 5.2 gallons per minute, where Elena's is at 4.8 gallons per minute, or you could say Julie's is filling up at a rate of 0.4 gallons per minute quicker than Elena's. Yep.
I did, the slope formula, but I put the decimals at the same denominator. I put the denominators at the same.
You still do the same thing? Yeah, that's fine. All right, we're not gonna do number 7. But I haven't even taught you all that still yet, so I don't think so much in this area. All right, number 8. Compare the slope of the equation with the slope shown in the ordered pairs below. Which one has a greater rate of change? So look at the equation they give you, look at the points they give you, and which one has a greater rate of change.